Hello, everyone. I thought I'll go ahead and explain this PowerPoint study sheet because it seems there was a lot of issues. So first of all, this study sheet takes you through step by step on how you can name a compound and how you can write a formula. So first of all, when you look at a compound, the first thing you need to do is identify if it is ionic or covalent. So here, how do you identify if something is ionic or covalent? Is by looking at the elements. If there is a metal and a non-metal in there, then the compound is going to be ionic. Okay, it's a given. So metal, non-metal. If it is ionic, it is going to have a cation, it is going to have an anion, because ionic compounds have ions in them. Okay, so once we've established that, now we need to identify the cation. So here the cation is always written first, which is calcium. So you write calcium, but that's not a cation. This is an element. So what is the cation? The cation is calcium 2 plus. Where am I getting the 2 plus from? This is because it's in group number 2 in the periodic table. Group number 2 is always plus 2. So it automatically becomes plus 2. All right. So calcium 2 plus. That is the cation in here. Now for the anion, it's going to be Cl. All right. So Cl is going to be the anion. But what is the charge on it? Again, it's in group number 7. So you find the charge for it because the charge never changes. So that's going to be -1. The formula is given to you, CaCl2, so we just have to write the name. Now for the name. So in the name, you have to write, of course, for the calcium and chloride. Because it's a metal and a non-metal, the first thing you have to do is figure out, is it a transition metal or not? It's not a transition metal. So if it is not, then the name is simply calcium chloride. Okay, let's do another one. So for N2O4, both of these elements, these are non-metals. If they're non-metals, then this is going to be a covalent compound. If it is covalent, then there are no ions in this. The naming system is going to be different here because for covalent compounds, you have to use the mono, di, tri, and all that. So this becomes then di-nitrogen tetraoxide. Okay, now let's look at the next one. So here we have calcium again, and luckily we've done calcium before, so calcium 2 plus. So automatically we know as soon as we have a metal that this is going to be ionic. Okay, so now let's look at the anion. This is written in parentheses, NO3 and 2. The 2 is there because that is the subscript that tells you that you have 2 of the nitrates. So 2 of the nitrates, then you figure out, of course, that NO3 is the polyatomic ion in there, and the charge is minus. And you have to memorize this, okay? There is no other way to do this. So memorize all your polyatomic ions that I've suggested to you. So now this is a polyatomic ion. Now for the name, again, metal and just a polyatomic ion, so calcium nitrate. The thing is that this is a main group element. For a main group metal, it is just simple calcium nitrate. Okay, if it was a transition metal, the nomenclature is going to be slightly different, which I will do for you in just a second. Now for HF. HF, hydrogen is a non-metal, fluorine is also a non-metal, so this is covalent. If this is covalent, no ions, and then this is going to be hydrogen fluoride. Now, some of you wrote this one as hydrofluoric acid. If you write hydrofluoric acid, okay, then you have ions in there. That means you need to write it as an ionic compound. But I didn't want you to because this was not about acids at all, okay, in this study sheet. Okay, so let's look at CuCl now. For CuCl, again, copper is a metal, so this is going to be ionic. So if that's ionic, then I know that I have anions and a cation. So my cation is copper, and the anion is going to be chlorine. Now for the charges. When you have a transition metal, you have to figure out the charge yourself. All right, so first of all, we look at chlorine then. So in chlorine, it's group number 7, and group number 7 has a charge of -1. And since the ratio here for chlorine to copper is 1:1, it means that if chlorine is -1, copper must be +1. So here it is +1. So for the main group elements, you can look at the group number, but for transition metals, you actually have to calculate that, all right? So now this becomes copper +1. Now the name for this one is going to be a little bit different because, as I said, copper is a transition metal. So for transition metals, you have to write copper 1 chloride. Now you can see in nowhere in the metals have I said that anything is dichloride or anything like that. Like calcium chloride is just calcium chloride. It's not dichloride, okay? Because that's how the nomenclature rules are. The other issue that I had when you wrote your study sheet is your subscripts and superscripts, okay? So when you write calcium ion, you have to write the 2+ as a superscript. If you write it like this is not correct, okay? So you can't do that. Similarly with NO3-, some of you wrote yours as, let me write this in a different color for you. So this is not correct, all right? Because this is not what it is, all right? So you need to be careful with your subscripts and superscripts. This is the language of chemistry and you have to follow that language. Okay, so I hope that things are becoming a little bit clearer for you. Let me just do maybe one more for the transition metal, okay? So let me just do FeSO4 here. So iron, again, this is going to be a transition metal. So let me write that here. This is a transition metal. So which means that this is an ionic compound automatically because it's a metal, right? So it has to be ionic compound. So now I need to find my anion and my cation. So this is my cation and I will fill in the charge in a minute. And then here is my anion. Now you have to identify that the anion is a polyatomic ion. You can't write S separately and then oxygen separately. It doesn't work that way. I will not give you any compound that has 3 elements in it, okay? So if there are 3 elements, then you probably have a polyatomic ion. Okay, so once you have the SO4, you have to know the charge yourself because, as I said, you have to memorize that. So SO4 is actually 2-, okay? So that's the sulfate. This is sulfate. So this is 2-, so which means if sulfate is 2- and iron to sulfate ratio is 1:1, then iron must be +2. So which means this is +2 or 2+, however you want to write that. So now the name becomes iron 2 sulfate. So in case of the transition metals, you have to include the charge as a Roman numeral. Okay, that is how we do it for transition metals. For the main group, you don't have to do that. So for calcium, I didn't do it. But for transition metals, I have to include the Roman numeral. I hope that was helpful to you in determining the nomenclature and this kind of a study sheet. Let me go the other way. Let me see this one, the other side of this. So here, potassium carbonate, for example, if you're doing this one, write the element first. So here you have potassium. Let me see what happened here to my pen. I think my pen is gone. Okay, so just hold on for a second. Okay, we're back. So here we are going to go ahead and do the other way, which means we're given the name, we're going to write the formula. So potassium carbonate, potassium tells me that I'm working with a metal, so which means ionic, automatically ionic. So then potassium is the element K, and then carbonate is a polyatomic ion. So that would be then CO3, 2-. Make sure you write your subscripts and superscripts properly. The charges are always written as a superscript, whereas the ratio is written as a subscript. So this is carbonate. Now, potassium is in group number 1, so automatically that becomes +1. You can circle your charge or you don't have to. This is my habit. I circle it. Okay, so potassium and then carbonate. Now, in order to write the formula for this, I know it's going to be KCO3, right? I have to combine this. But what is the ratio? So this is where you do the crisscross method. So you take this one And then you go ahead and you do the crisscross, which is then taking the 2 minus down here and the plus 1 down there. And so this becomes 2. And then case the carbonate is just 1, okay, because it was plus 1 over here. So that is how you would write the formula, okay, for potassium carbonate. So you can go on and on. You can see here tin and lead I gave to you because tin and lead are exceptions for the main group elements because tin and lead have +2 and +4 valencies. So in that case, you have to write them as transition metals, even though they're not transition metals. So as I said, metals, so it means that they become ionic. Ionic calcium again is ionic. I don't know why I have so much calcium in here. Anyhow, so then hydrogen chloride, non-metal covalent, so take it like that, all right, step by step, and you will see that it'll all work out. I hope that was useful. Let me know if you need any more help, okay? I can definitely meet with you.